Today I'm going to give you an elementary introduction to the mathematical notation of functions. That sounds like a lot, but it really isn't. It is extremely important because the Python language very much so mirrors some of the notation that is used in math. And I'm not necessarily sure that at your version of algebra or pre-algebra that you may be in right now, that you would have seen this notation. So we're going to work with some very basic concepts because that's all that we're going to do in this course. But this notation is extremely important. If after watching this video you still have a lot of questions or you're confused by something, make sure to let me know so that I can help you work this out, because this really isn't that difficult, but the notation is definitely different from what you've seen so far with your mathematical experience. All right, so let's begin. I'm going to work with an example, and we have to have an objective for this function. Now, a function is just like a set of rules. It's a process. It defines, given some input of information, what am I supposed to do with that? And what is the result going to look like? So we see in this assignment that you read about, a machine that can take plastic or cardboard, and the machine does something to that material, and then out pops a new object that is composed of that initial material. Well, we're going to do that with math now. So our objective is going to be, we're going to take some number, we're going to increase it by 1, and that new number is going to be considered our outputted result. Here's a specific example. We're going to input the number 6 into this function, and the output of that function is going to be the number 7, because it follows what the objective said. We put in a number, we increase that number by 1, and then out pops the number 7. Okay? So that process of increasing something by 1 goes inside that function box. All right? Now, mathematically, you should have seen something like this. We can write an equation for this process. You take some number, we're going to assign that number a variable. So we're going to assign that variable x. And we want to add 1 to that variable x. And then the output is going to be our y value, which is, depending on what our input is, that's what the result will be. So let's see. Okay. So we can write this as y is equal to x plus 1. Now, another thing that we can actually do is we can come up with a name for this function. We don't have to just call it function. We can call it something. So why not let's call it f for function. All right. That's what we commonly do. We usually choose f or some other letters, but let's think of f for function. Well, we can write this in this new notation, and this is the whole objective. I want you to be able to understand what this notation means. So instead of drawing a picture with a number 6 and an arrow going into a box that we've called F, and then an arrow pointing out with the 7 on the other side, instead we can actually write the letter F, the name of the function, a pair of parentheses, and inside those parentheses is going to be our input value. So we want to calculate what f of 6 is. That's what we'll say. We'll say f of 6. And then the output, we put equals, and then whatever that outputted value would be. So in this example, we have x plus 1. So whatever number we put in as our input, we get a 1 increased on that out. The general formula, the general equation that can represent this concept would be f of x is equal to x plus 1. That allows us to choose any number, and we can represent x by any one of those numbers. So for example, and this won't appear on the screen, just listen to this. If I was to draw out f parentheses 8 parentheses, well, what is that equal to? That's equal to 9, because we're inputting 8, we add 1, and then we get 9 out. So our function that we have named f is really a set of instructions that are considered to be reliable. Every time we input 6, we always get 7 out. This would not be considered a function. Okay, this is important. This is not a function if every time we input 6, we get a different answer out. We need our functions to be considered reliable. Now, the term reliable is not a mathematical term. We have a very special way of writing that. But for this course, that's acceptable enough, okay? Our functions must be reliable. I put in a number, and every single time I put that same number in, I should get a similar result out. If I don't, there's something wrong, and we would not consider that to be a function. All right, so now that we've seen this notation, I mean, that's it. The notation is that simple. Let's try and calculate a few problems. So what I'm going to do is I give you a problem, you should try it out, and then I'm going to give you the answer and see if you get the correct answer. So first, calculate f of 3. You can pause this now and then hit play again when you're ready for the answer. So we input the number 3, and so we add 1 to that, and then the result will be 4. So we write f of 3 is equal to 4. Next problem. What is f of 99? So pause this and draw out your calculations. F of 9 is equal to 100. All right, so here's a practice problems page. We changed things up a bit. So we had one definition of our function. It was x plus 1. You put a number in and then you add 1 out. Well, we can redefine that. It doesn't have to be just that. It can be anything, any mathematical process. So I have 3 problems here, or 3 definitions, and each definition have 2 different problems that you should work out. The first problem is define f of x is equal to x squared. All right. Remember, if you don't know that notation yet, this x to the exponent of 2, that just means whatever number you put in, multiply it by itself, and that's the answer. For number 2, we have defined g of x is equal to x minus 3. So whatever number we put in for x, we're going to subtract 3 from that, and that answer is our result. And then the last one, this is an interesting one. We define a function and we don't just use a letter, we actually use a word that relates to the process. So I'm going to define this function named sum, and it's going to take 2 input values. It's going to take an x value and a y value, and it's going to add those 2 numbers together, and the result is going to come from that. So let's work through each of these. Calculate f of 2, and the answer for that is 4. 2 times 2 is equal to 4. Calculate f of 3. F of 3 is equal to 9, because 3 times 3 is 9. Let's go on to number 2. So let's calculate g of 3. You plug 3 in, and you subtract 3 from that. So g of 3 is equal to 0. Calculate g of 0. What is 0 minus 3? You go to the left on the x-axis or on your number line into the negative numbers, okay? And that answer is going to be negative 3. Finally, let's calculate the sum of 2, 3. Well, what does our instruction say? It says to take those 2 numbers you input and add them together. So the sum of 2, 3 is equal to 5. And then the sum of 100, 100 is equal to 200. If this concept and this notation make sense, then you're ready to move on. I'm going to have a practice quiz that you can try with similar problems like this, and that will count towards nothing. It's for your own practice. Once you've successfully completed that practice quiz, there will be an actual quiz that will count as a grade. For each one you get correct, you'll get a certain amount of points, and the total of those would be what that assignment is worth. So don't take that until you're really ready for it, because you take that once, and then whatever grade you get, that will be what your points are.